4.2a, characteristics of quadratics. I want you to write down something to start off with, okay? When we talk about the vertex, you should know this, but negative b over 2a, comma, question mark. Okay, that's going to be the vertex. I'm going to write that again. Negative b over 2a, comma, question mark. So the question mark is just you plug in that number. Whatever you get for negative b over 2a, you plug it in. That's going to be your vertex. That's going to be important for some of the problems today. And then also, you should know that when they talk about domain, they're talking about x numbers. And when they talk about range, they're talking about y numbers. All right, so get that down. Make sure you know that's kind of background information. You should probably already know that, but that's going to come back in this lesson. So it says, sketch the graph of each function, then find the following. So we're going to have to sketch them. Notice that all of these things are going to be parabolas. You can tell because they've got x squareds in them. But the first question, or part A, says, is there a maximum or a minimum? Well, look at the function. You've got a negative x squared. If you've got a negative x squared, you should understand that it's going to be an upside down parabola. Okay? So when they ask that first question, if there's a maximum or a minimum, they're talking about the vertex. And that vertex is the high point. So I would absolutely call that a maximum. Is there a maximum? Yeah, there's a maximum. That maximum is called the vertex. So part B, I know sometimes students get confused by this question, but they're just asking you for the maximum value, all right? So they're asking you to find the vertex. So we have to do that negative b over 2a. And remember how to do that. You know that this is the a coefficient and b and c. So you would plug in to negative b over 2a. This is going to be negative 8, that's your b coefficient, over 2 times negative 2, that's your a coefficient. So clean that up. You've got positive 8 over negative 4, which is negative 2. That is the x part of your vertex. That's the x part of your vertex. Now you need to fill that in to find the y part of your vertex. So I'm absolutely going to use a calculator for that. You take your equation, and your equation says negative 2 times, and our number we need to plug in is negative 2, squared minus 8 times our number, which is negative 2, minus 7. Plug all that in, use your calculator, you get 1. That's this y number right there, 1. And that also happens to be the maximum value. The maximum value is 1. But they're just talking about the vertex. If we look at the vertex at negative 2, positive 1, there we go. There it is right there. Negative 2, positive 1, that's our vertex. Now, we can go ahead and graph it before we talk about domain and range. We know it's a parabola because of the x squared, and parabolas are going to have that 1, 3, 5 pattern. But because this has this negative 2, that acts like a multiplier, and so I'm actually going to multiply my pattern by 2, and this turns into a 2, 6, 10. Now, of course, if you didn't want to talk about the pattern, the 1, 3, 5 pattern, you can always do an XY table and plug stuff in. But I think this is much easier. So I'm going to go from that point, I'm going to go down 2 and over 1. And then I'm going to go down 6 and over 1. Draw a nice smooth curve through those points, and you're going to have your parabola. Kind of tough. Okay. Now, when we talk about domain and range, most people just memorize domain is the x numbers, range is the y numbers, but there's a little bit more to it than that. When I talk about the x numbers, I mean, what am I allowed to plug into the equation? So sometimes you're allowed to plug in everything, and so the domain would be all real numbers. Sometimes you're not, and it's restricted. Okay, sometimes numbers don't work or can't work. But anyway, the way I like to look at domain, check this out. Let's take a parabola, and what I like to do is just squash it down onto the x-axis. If you want to know the x numbers, just visualize squishing this thing onto the x-axis. Okay? If you do that, if you visualize, look at this. Okay? You see how, look at the x numbers right now. See how all the x numbers are between -2 and +2? There's nothing outside of that interval there. From -2 to +2 is the domain for this. Those are the only possible x numbers for this graph. All right, so the domain for this example is from -2 to +2. That's the domain. Okay. If I go back to my example here, it's a little bit weird, but notice how the arrows extend this thing forever and ever and ever. Right? We're gonna go on forever. We're gonna keep on spreading out forever and ever. So if you think about just the x values, if you squash this onto the x, it's going to end up covering everything. This one in particular is going to end up covering everything. If you look at the equation, what that means is you're allowed to plug in any x number you want. But the domain, we can say the domain is all real numbers. So let's use that fancy looking R. It's like a capital R with an extra stick on it. So write that. That means all real numbers. That means everything. Now, if you look at the range, check this one out. If we're talking about range, we're talking about y numbers. So what I like to do on a graph is I just visualize if I took that graph and I squished it onto the y-axis. If you squish it onto the y-axis, then the y numbers become clear. In this example, the y numbers seem to be going from -2 to +15. Those are the only y numbers that will happen on that graph. So I like to think about squishing it onto the y-axis. If I do that for this example, then it doesn't cover everything. It only covers from +1 and down, right? It covers all of the numbers that are less than or equal to +1. And so what I can say for the range here, I can just say y is less than or equal 1. Now, there are other ways of saying it, but I think that's probably the simplest way of saying it. Y is less than or equal 1. For the solutions, when we talk about solutions, we talk about zeros. We want to know where the graph crosses the x-axis. We want to know those two numbers right there. What are those x numbers right there? And it's difficult to say. You can kind of estimate. If you've drawn a good picture, you can get it a pretty good guess. All right. To me, it looks like about -1.3 and -2.7. That's what it looks like to me. We can actually do a little bit better. Check it out if you want. Okay, if you go to Goldadder and go to the math sites, you'll see that one of them is a quadratic formula. And what we can do is enter the coefficients. So if you go back to the equation, you had -2, -8, and -7. So I can do -2, -8, and -7. And hit solve. And you can see it draws a little graph there. And we've got the vertex at -2, 1. And it looks pretty much the same as what mine looks like. But check it out. It also solves it for us. And it says x is approximately -2.7 and -1.3. That's about what we thought, right? So we think those solutions are about -2.7 and -1.3. Those are the solutions. Those are also called roots or zeros. So it should get easier after you've seen the first example. Here's the second example. Right? We know it's a parabola. You can tell because it's an x squared, it's going to look like this. It's a positive x squared. So this point right here, this vertex point, is definitely a minimum. If we want to find that minimum, we can do -b/2a. So let's do that. Negative 6 over 2 times 1. That's going to be 6 over 2, which is 3. Remember, that's the x coordinate of our vertex. So we need to plug that 3 in. So go back to your calculator, and we're going to plug in that 3 into the equation. So remember, anytime there's an x, I put parentheses. So it's going to be 3 squared minus 6 times 3 plus 6 gives us negative 3. There's our vertex, 3, negative 3. But that also tells us our minimum number, negative 3. That negative 3 is our minimum. We can draw this parabola because we know it has a 1, 3, 5 pattern. There is no multiplier because the coefficient is 1. The a coefficient is 1. So it's just going to be 1, 3, 5. Be careful on this one. Sometimes people mess up because of the tick marks. We're going up one number, not one tick mark. So if I go up 1 and over 1, that puts me right here and here. If I go up 3 and over 1, that puts me here and here. Again, I'm looking at the units, not the tick marks. So I'll draw my parabola through there. And try to do your best. It's not going to be perfect, but it should be pretty good. And then for domain, remember domain, we squash it onto the x-axis. That's domain. Okay, we look at the x numbers. And the domain of this is going to be all real numbers. Was that part C? Yeah, part C is the domain. If we look at the x numbers, it's going to extend on forever and ever. There's nothing that's not covered. So part C, the domain, again, is all real numbers. Part D is the range. The range is when you look at the y numbers. So if I look at the y numbers, remember how that works. I visualize squashing it onto the y. If you only look at the y numbers, or if you squash that over onto the y axis, it's going to cover everything from negative 3 and up. Okay, so another way of saying that, y is greater than or equal negative 3. There are other ways of saying that, but that's one way. We want the y numbers that are greater than or equal negative 3. That's the range. That means that whatever number you plug into that equation, your answer coming out is going to be some number that's bigger than or equal to negative 3. You'll never get negative 4 as an answer. All right, so lastly, we need to talk about the solutions. And there's one and there's one right there. So what are we looking at? 1.3 and 4.7 maybe? 1.3 and 4.7? We can guess 1.3 and 4.7. If we've drawn a good graph, we can usually get about within 1/10. That's what I think it is, 1.3 and 4.7 based on my picture. But we could, actually I don't need to do that. We could go back to this website again. Okay, so let's clear this out. My coefficients were 1, negative 6, and positive 6. So here's that graph. Again, double check the vertex, 3, negative 3, looks like ours. 4.7 and 1.3. Yeah, that's pretty good. So part E, the solutions, 1.3 and 4.7. Okay. Now, as we go to the back looks different, okay? And believe it or not, that's a good thing. Even though number 5 looks like it's going to be harder, it's actually easier because it's written in vertex form. We talked about vertex form last chapter, but I know some of you may have forgotten this. This vertex form, I always like to look at it as what number makes 0. That's negative 2 right there, okay? That's negative 2, and if that's 0, then all you're left with is 3. But in vertex form, I can literally see the vertex is going to be negative 2, positive 3. The vertex. is negative 2, positive 3. That makes it easy. Negative 2, positive 3. I still know this is going to be a parabola because it's got an x squared in it. It looks more complicated, but if you imagine multiplying that out and foiling and just, whatever, you're going to have an x squared in there. So it definitely looks like a parabola. But then we've got this number in the front. So it's going to be an upside down parabola. Okay? And what that means is that vertex is a maximum. It's the high point. It's the maximum. So part B, what is that maximum? Well, that's just the y number on my vertex. That positive 3 is the highest point of my parabola. That's got to be the maximum. Now, if I'm going to graph this, since it's a parabola, we could say, well, this is going to have a 1, 3, 5 pattern. However, there's a multiplier on there. It's going to be, once you multiply that all out, it's going to be negative 2x squared. And so I've got to double my pattern. It's going to be a 2, 6, 10 right there. So from the vertex, I'm going to make sure it's an upside down parabola. So I'm going to go down 2, and then I'm going to go down 6. And it looks something like this. If you look at the domain, well, again, this is going to go on forever. It's going to cover the whole x-axis. If you look at all the x's, it's going to extend out to the left and to the right forever and ever. This domain is all real numbers again. The range is only going to cover these y numbers. So y is less than or equal to 3. Y is less than or equal to 3. Now, we look at those solutions. It's going to be here and here. If you try to plug into this website again, you can't exactly do it because this website is only set up for standard form. This website is not set up for vertex form. You wouldn't know where to plug the numbers. So, I mean, you could simplify this out and FOIL this out, but I don't really need to. Let's just estimate. What do you think this looks like? Negative 0.7 and negative 3.3, maybe, ish. Okay, about. It's just going to be an estimate. So I'd say that looks about like negative 0.7 and negative 3.3. That's my guess. So then number 7, it's basically the same idea. You can see the vertex is going to be negative 4, positive 4. Negative 4, positive 4. If you can graph it. Come on now. All right. Because of this negative, we know it's an upside down parabola. We still have an x squared. It's still a parabola. We're still going to have that 1, 3, 5, but we know it's upside down. Okay? But if it's upside down, then that means that vertex is a maximum. Well, what is that maximum? Well, it's just this y number. The maximum is that positive 4. It's the y part of the vertex. So we've got our 1, 3, 5 pattern. There is no multiplier, so let's just go down 1 and then down 3. We look at the domain. And again, the domain is going to cover the whole x-axis. That's all real numbers. We look at the range. The range is only going to cover from 4 and down. Remember, 4 was the maximum, right? So everything from 4 and down. Or how about we say y is less than or equal to 4? As for your solutions, this time it's easy because we've already got them marked and they're right on the money. There's one at -6 and there's one at -2. So your solutions are at -6 and -2.